Identificar nuevos casos de uso en inteligencia artificial, ponerlos en marcha y recibir un retorno de la inversión muchas veces es algo complicado para las empresas. De hecho, algunos de estos sistemas implementados de inteligencia artificial se quedan un poco en el departamento de I+D. Nosotros no queremos que esto ocurra, por eso esta sesión es importante. Queremos que las empresas aprendan a implementar esta inteligencia artificial y por eso vamos a hablar, porque ya está preparado, con Boris Korder, Senior Director, Partners and Alliance de DataRobot. Welcome back.
Welcome back, Adrian. Hi.
Before starting, let me tell you something. A few days ago, I read that there are only about 10,000 hardly qualified people in artificial intelligence. I think that you are one of those 10,000 people, so it's not a pleasure but a privilege to have you today here.
Thank you.
So let's talk about artificial intelligence and automated machine learning. That's your question today.
That's my talk today exactly. I thank Adrian, thank you and Arno for this good introduction, this good overview of what AI, machine learning, and also automated machine learning is all about. And what the DataRobot platform, including Paxata, is all about. In my presentation, I said I will give a little bit of context at the beginning to create a common understanding of what we mean when we talk about machine learning, automated machine learning, and then I will build on the things that Arno already laid out, and I will walk you through a real-world scenario and show you not only on slides but also in the application how DataRobot works and how someone who is a data scientist or perhaps is not a data scientist could work with the platform and could also implement AI solutions and build models, even if you do not have programming skills or if you do not have math and stats skills. So you have to understand the business, you have to understand the data. That's important. But then you're able to work with a platform like DataRobot, and that's what I want to show to you. So I hope you can see my presentation. No more training camps, better predictions faster. That's what it's all about. And I would like to start with a short quote. And I think these 75% of executives that believe they risk going out of business in 5 years if they don't scale AI, the 75% is impressive. But I think there's another word that's very, very interesting, and that's the word scale. Because a lot of companies already, they implemented BI platforms. They do analytics in different kinds of areas, and they already started thinking about how AI can contribute to their business, to reduce costs, to increase revenue, or to optimize other things. So it's not completely new, but what is relatively new is that companies recognize that they have to find an idea how they can really scale the implementation, the creation of AI models and applications, because they see that the business is asking for solutions. They have a lot of ideas in all the business departments, but there are not a lot of people who are really able to build these kind of models. And you have to have extensive expertise in programming, in math and stats. You have to know the data. So there is a lot that you have to know when you want to build these kind of models. And there are not a lot of people out there with these skills. You have heard of the data scientists, but if you look for real data scientists, not the data scientists that just change their LinkedIn profile to get a higher salary. So for real, if you look out for real data scientists, that's not easy to find them. Therefore, scaling these activities and increasing the productivity, that's a huge topic. So let's talk about AI, and perhaps you have seen these kind of images, these kind of human robots, whatever these people are. To be honest, I'm not a fan of these images. We sometimes use them as DataRobot also, but I'm not a real fan because it leads us into a wrong direction. That's not what we want to talk about. It's not about holograms. It's not about robots that have human faces or corpse. So that's not what we're talking about. What we're talking about is machine learning, and perhaps you have already heard of machine learning. Sometimes you have perhaps heard of deep learning. Some good example that went through the press is that deep learning powered solutions have won competitions in chess or Go or even poker. So this is where deep learning is doing some interesting stuff. But also, if we talk about self-driving cars, if we talk about visual AI, often deep learning approaches are needed. Neural networks are needed as part of the overall machine learning approach. The overall machine learning approach, I like to talk about it as a two-step approach. And if you think about this two-step approach, it's at the end relatively easy what it is all about. So the first step is that we take historical data and that we analyze the data and that we make some observations to build a model. And then when we have this model, we apply this new model to future data. So in the first step, it's about historical data, and we will see how we will work with historical data in the demo. And then in a second step, we use a model that we created, and we apply this model to make predictions. So the DataRobot platform, it's all about make good, very good, high accurate predictions and make them very fast. When you look at AI applications that are used today, some of them we would say are powered by boring stuff, so kind of rules that companies are using. You could challenge if this is already AI or not, but you could say it's AI. It requires some kind of intelligence that usually only human people could do and provide. So some of them are powered by these kind of rules. Not a lot of them are powered by deep learning, and not that companies do not try things out and train models. When I talk about these applications, I mean applications that are in production. There are not a lot models, not a lot real AI applications that are already in production. But out of them, only a very few are today really powered by deep learning approaches. And the majority of these solutions that are used today in a productive environment are powered by this machine learning approach that I just mentioned, this two-step approach: use historical data, build a model, apply this model to future data, and as a result, come up with predictions. And what's super important, and I cannot underline this enough, and you will see it throughout the entire presentation, and also Arnaud mentioned it a couple of times, it's we do not build AI models or train models to have trained models. That's not the idea. The core thing is that we want to bring these models into production so that they can really create business value, in a sense that they automate things, that they optimize things, or sometimes at least they provide some actionable insights. For example, as part of a BI platform, as part of an important dashboard where you visualize the predictions, and then you make some decisions based on this data. So it's important that we do not only train, we do not want to stay in a training camp. We really want to go into production. to create this perfect mindset, I would say, for what we do, what DataRobot can support with, I think it's just a simple question that you can ask yourself. And you can ask yourself, okay, where are you able to realize significant returns? For example, reduced costs or increased revenue, if you would be able to predict something faster and or better. And you can just look at your processes that you have in place today. You can just have a look at your business, have a look at your data, and ask yourself this question. And I bet you will come up with a lot of ideas. And that's also something that we see as soon as the business starts to think that way. They come up with excellent ideas where this machine learning approach really could add a lot of value. And there are companies out there who are already doing this today. So in the insurance space, for example, in this example, domestic in general, what they do is they calculate the optimal price so that you sign up for a new insurance, right? And you see that they end up having 500,000 to 1 million price quotes they have to calculate per month. And I mentioned the word scale at the beginning of this presentation. And this is, I think, a perfect example that these number of quotes, these number of models that you would need for different products, different customer segments, this is not something that you can build in a very manual approach. You need some automation to do this. Another example is Kroger, one of the largest retailers in the UK. What they do is they analyze the shopping baskets from their customers. They use a lot of these loyalty cards, so they have a lot of data. So all the promotions they send to you via email or via mail, it's totally personalized due to your preferences, and they are able to predict at a very, very high level what you will probably purchase, what you will buy during your next visit. So this is a really very, very well known and very important use case and example in retail. The Harmony example when it comes to credit risk, this is something that I will show you in the demo. So I will not talk about this in more detail, but it's about predicting the probability that a loan will default in the future. But we will see this in the demo. Then you might have heard of predictive maintenance. If you want to predict faulty parts of a machine, can be a big machine, can be an elevator, for example. These are very, very important use cases. A lot of sensor data that we can analyze. With huge throughput, with more or less in real time, where we are able to provide these predictions, so that, for example, the service can go out to the end customer a lot earlier and ideally before a part breaks. Last but not least, sports seems to be a very, very typical US slide with basketball and baseball and football. But we also see this more and more in Europe. For example, we just had an event with Manchester City. They talked about how they use a DataRobot to predict, on the one hand side, what's happening on the playing field. So they analyze all the data that they get from the playing field during the matches, but they also analyze very, very commercial use cases and use DataRobot for very commercial use cases. For example, they predict the probability that someone will not continue or renew his annual ticket. So typical examples, or for example in merchandising, this is also a very, very good area for DataRobot. Yeah, and then more important than ever, when we talk about COVID, when we talk about flatten the curve, at the end, that's AI, that's machine learning, and we do a lot in this space. Also, for example, in hospitals, where we try to reduce the patient lengths, or where we help the hospitals to predict their staffing, right? And in this example, it's interesting that the Steward Healthcare, this chain, hospital chain in the US, they recognized that the schedules of the sports club, for example, the New England Patriots, a football team, that their schedule has a significant impact on the people that show up in a hospital. And therefore, they're not now able to do their staffing accordingly. And as you say, a good example in the healthcare system, in a healthcare business. And just as an example, in the healthcare industry alone, these are all these bullets that you see on these slides are all examples for very, very good use cases. So you see, there's a lot out there that can be supported by a machine learning approach and a platform like DataRobot. But then when we look at customers, when we talk with customers, we recognize, hey, there are a lot of use cases out there, but there are not a lot of use cases really creating a lot of value today. And there are reasons for this. The first reason is that most of the customers, they experience significant problems with model development. So it takes a long time. Arnaud mentioned it, the different phases, depending on the complexity of the use cases. This can really take time. Then as soon as you have trained the model, it's not that you want to have a trained model, you want to have that the model produces predictions that you can use. So you have to bring it into production. And most companies fail, at least at scale, to bring these models into production. Sometimes because due to technical reasons, but mostly because they do not trust the models that have been built by a data scientist or the data scientist teams. And not because the models are wrong, it's just because they are not able to understand it. They have not a documentation. They cannot interpret what the model is doing. Yeah, no transparency. It's more or less a black box, and you would not deploy a black box. That's the core problem. And even though you have put models into production, more or less no company today, or only really a few ones, really monitor and manage their assets in production properly. And if you think about this two-step approach, please have in mind, you trained a model based on historical data, and you do predictions based on future data. And we all worked with data already, and you do this perhaps on a daily basis, so you know that data changes over time. We all know this. So it is more than obvious that over time, the data that you get, the future data that you get, changes from the data that you initially used to train the model with. And you always have to monitor how the data changed, if you perhaps have to change the model, adjust the model. And if you do not do this properly, there is a huge risk that you have models in production that are not very accurate, or perhaps really provide really bad results. So there are reasons for these stats, and just three analogies. I like to use this analogy to make transparent that it's not about the most complex use cases. Sometimes we find customers who take the most complex use case, and it takes them months to come up with a first model. So sometimes you have use cases that are that complex, but at least you should look for use cases that are not that complex, that can create that can also create a lot of value, and you have to find a way how you can develop and bring them into production more quickly and really scale. Yeah. So do not take only one use cases and spend months about this use case. So it's about automation. Perhaps you know this guy. So the key question is, where do you know this guy from? Yeah, it's definitely not the training camp. It's definitely not the gym. Perhaps some of you, I don't know, but I think it's because he got a lot of return from his investment on in a training camp or on a training court or in the gym. Yeah. So it's not just about training. You have to bring it into production to really create value, to really have results. And last but not least, if you like watches, this is a very nice one from Patek Philippe. I'm not very familiar with watches, so I know it's 10 past 10 on this watch. My brother is selling these watches, and he has to understand how it works. So I'm fine with 10 past 10. My brother would like to understand how the watch really works, so that he can trust, okay, that's the exact time that the watch is showing. So to all support these things, we implemented a platform that we are currently providing on different deployment options on our managed AI cloud service that I will show you now in the demo. It's built on, or currently running on the AWS platform. And just to give you an idea, on a daily basis, we train and deploy between 2.5 and 3 million models. So it's a platform at scale, and we provide all these different steps that are needed throughout the entire life cycle. So it's about the preparation of the data. It's about feature engineering. We have to directly deploy the model within the platform. Then we have to monitor and manage the models that are in production. And last but not least, it has to be very easy to integrate the models, the predictions that DataRobot generates, to integrate these predictions with other applications. For example, with a BI application, with an RPA application, or with other line of business applications. I am not a data scientist. I would call me perhaps a business analyst. I understand the business. I understand the data. I'm not able to do any programming. I'm not able, or have very limited math and stats expertise. So you see that this platform is meant for different kinds of audiences, and that's important. It's also meant for different kinds of data. So in this example that I will show you, we will see some text data, we will see numerous data, but it would also be possible to, for example, upload images to DataRobot to do image recognition and to do use cases that are built on images, for example. Yeah, and as said, you can deploy this platform on any infrastructure. You can use our service, or you can run it on your own private cloud in AWS, in Google Cloud, or Azure, or even if you say, hey, I want to run it in my own data center, you could also do it. Good. A little bit of context now. Let's have a look at the DataRobot platform, and let me go back to the browser and just give you a little bit of context what we will see in the demo. I will use a real-world scenario based on this Landing Club platform. This Landing Club platform is a peer-to-peer lending platform. So what you can do, you can create a new loan. So if you want to get money, perhaps if you do not want to go to a bank, or perhaps if the bank has said, no, we will not give you any more money, there are these peer-to-peer lending platforms that you can use, and you can apply for a loan. And on the other hand side, you have investors. And in this scenario, let's imagine we have some money left, and we want to invest in these kind of loans. What we want to avoid is that we invest in a loan that defaults. So we do not want to invest in something that will not be paid back. So we will now use DataRobot to provide us with a probability if a loan will default or not. And based on this probability, we can then decide if we want to invest in a certain loan or not. So that's the scenario. This is the data that we will use for this small example. It's a small data set, 10,000 rows, so 10,000 loans that we have in this data set. And you see here we have some core information about the loan. So we see the loan amount. We see the term, 60 months or 33 months. Lending Club already comes up with an internal assessment. They come up with already with an interest rate. This interest rate will be important for us. Then you see some information about the employer, so the person who created this loan, who is he working for, what's the annual income, obviously very important to what we want to predict. Then we also see that we have some text. So for example, there is a title, and we see here, for example, someone is needs a loan for a wedding. I like this one, and it is a real data set, so no fake. The real data, the real loan here has been titled Survive, but this loan has been paid back, so it's historical data. We know that it has been paid back. Perhaps Survive is not a bad title for a loan. Then some more information. I will not go into detail. One last column that I want to highlight, and that's the column is bad. Perhaps you have already heard of a supervised versus unsupervised learning approach. This is a supervised approach because we have this column. And I said that it's a two-step approach. We have historical data. That's the historical data set. And you see that based on the historical data for these loans, we already know which ones of them faulted or not. So 0 means it is not bad, so it has been paid, it's good. And where you have a 1, it is bad. So this loan has not been paid back. So ideally, these kind of loans are not the loans that we will invest our money in. Now let me go back to the browser and let us have a look at DataRobot. So this is the platform. As said, this is the managed AI cloud service that we run on Azure. And I will not cover the data preparation part because we have already seen the data file that we will now use. So I will not cover Paxata. What I will do now, what I will start with is that I want to upload data into the platform that I want to use to build a model. So connect to my historical data. And you see there are different options of how I can connect to historical data. I can connect to a database, I can upload a local file, I can connect to a Hadoop file system, or what I will use the AI catalog. The AI catalog is a catalog where you can predefine different kinds of data sources that you perhaps need or will need, or that you use for different kinds of use cases, different kinds of models. And in this case, I already have uploaded the data set that you have just seen to this AI catalog. That's the AutoML Lending Club data set. And I will now create a first project. So what DataRobot is now doing is DataRobot uploads the data, the CSV file that you have just seen, uploads it to the DataRobot platform. But DataRobot does not only upload the data, it also does a first, we call it exploratory data analysis, EDA. So a first analysis of the data. And that's also something what typically a data scientist would do. So for example, if you think about a business department who hands over this Excel file, this data to a data scientist or to a team, the first thing that they would do is they would analyze the data. They would have a look at the columns, the rows, to have an understanding, okay, what's in the data set? What's the data all about? But this is something that DataRobot has already done. And you see it only took me a couple of seconds. And now you see that there's a list of all these features, and we call them features in DataRobot. These are the columns that you have seen in the Excel file. And for example, you see the loan amount that I showed you in the file. And you see that DataRobot is analyzing what kind of type is it, the unique missing values, and some other stats. And I can also click on all of these features and get an idea of the distribution of the data. So that already helps me to understand where data is missing, if data is missing, how the data is distributed within the file. Nothing spectacular, but in terms of productivity, that has been very fast. But we do not want to analyze the Excel file. That's not the idea of DataRobot. What we want to do is we want to predict something. And if you remember the last column that I showed you in the Excel file, the flag, that is exactly what we want to predict, the 0 or 1. We want to predict if a loan will default or not. So DataRobot asked me, what would you like to predict? And it's the column is bad that we want to predict. So I choose is bad, and you see that DataRobot already recognizes, okay, this is a binary classification use case. So the result is 0 or 1. The flag is 0 or 1. We could also do multi-class. We could also do regression. And we could also do, you see this on the right-hand side, I will not cover this in this demo. We could also do time-aware modeling. So time series-based use cases. For example, if you want to predict the revenue or cost or staffing over something over time. Yeah, so typical COVID curve, this would be a time series-based use case. In this case, we have a binary classification, and we see that around about 18% of the existing loans that we have in our historical data set are bad. And then you see a big start button, and now I will click on the start button, and DataRobot will start to train the models based on the data that we uploaded to the DataRobot platform, and based on the target variable is bad. What DataRobot is now doing, I want to describe based on another slide. Let's stay with the tennis analogy and with Rafael Nadal. So let's think about a tournament, a tennis tournament. What DataRobot is doing is that DataRobot has an extensive library of so-called blueprints. Blueprints are different AI algorithms from all the well-known libraries like R, Python, TensorFlow. So we include them into the DataRobot platform so that you do not really have to, as a citizen data scientist, you do not have to know all of these algorithms. But what DataRobot is doing is based on the data that we provided and based on what we want to predict. DataRobot in the first round of the tournament picks 30 to 40 different kinds of blueprints. DataRobot thinks they could fit very well to predict the probability, in this use case, the probability that a loan will default. After the first round, the 50%, the best 50% of the blueprints will go into the second round, and we give them the 30% instead of 16%. In the second round, we double the amount of data. We provide them with 32% of the data, and we train them again. And then in the third round, we do this again with 64% of the data. And last but not least, at the end, we will have a recommended a model that DataRobot recommends for deployment. So the most accurate model that we have trained based on this concept. So this is what we call the autopilot mode in DataRobot, and this is exactly what DataRobot is now doing. And let me zoom here a little bit, and let me increase the number of workers to 20. The workers are at the end are compute nodes in the background that we use to train the models and calculate the models. And now you see that, and I highlight this because then it becomes clear that this is nothing that a data scientist could do that way in terms of productivity. In parallel, DataRobot is now processing up to 20 different models. And you see here different kinds of icons. You see a little robot that's a DataRobot model. You see an XGBoost model, a Python model. So think about a data scientist, perhaps a data scientist who just finished the university and who knows to work with a couple of algorithm. He has his favorite algorithms, his favorite libraries, but now DataRobot is able to bring the assets from all the libraries and really picks the best algorithms for this data and this use case. So let's in terms of the time, let's DataRobot run this tournament, and I will go to a second tab that I just built, and you see that here we have a leaderboard. So let me go back to this one where DataRobot is currently doing the tournament. As soon as a model has been trained, what would you also expect from a real tournament? It goes to the leaderboard. And if you click on models, you see that here we have a leaderboard, and you see that currently this model, so the light gradient boosted trees classifier with early stopping, is currently leading based on the metric log loss that we use for the optimization. And you see here, it has already worked, already trained with 32% of the data. It will change over time, this leaderboard, up to the end of the tournament. So therefore, I'm going to the second tab here. It's the same data, the same use case, but now the leaderboard is finished, the tournament is finished, and you see that we have a model that is recommended for deployment. So if we would be a business department and the data scientist would say, hey, I have the gradient boosted trees classifier with early stopping for you. Do you want me to bring this into production? Do you want me to deploy it? I would say, okay, that's nice. Seems to have a good accuracy, but I don't want to bring this into production because I do not understand what this model is all about. If it is doing really good predictions, why it is doing good predictions. So I do not have the transparency. It would be a black box. Let me take another blueprint here. Now let me click on that one. And then you see, okay, here we open this black box and we provide the users with different kinds of documentation and transparency. So the first thing is that here you see the blueprint, and this small box here at the end, that's the algorithm. But you also recognize that there are a lot more boxes here. You see data that we have to differentiate the data. These are categorical variables, and we have to do some encoding. If these are text variables, we have to convert them to do text mining. If there are numeric variables, for example, we have to impute missing values. And these things, these steps are automatically done by DataRobot. So you do not have to do them manually. So that's one thing. Then also when I click on this model and I can directly open the DataRobot description. So for each box, I would get the documentation. So the data scientist or data scientist team would not have to document all the steps anymore. This has been done by DataRobot. And then it becomes more interesting because you can have a real business-centric discussion with the team around the use case and what the model, the blueprint is all about. So for example, this feature impact matrix shows that the annual income for this specific blueprint is the most important feature, followed by the description. And that's interesting. So when we want to predict the probability that this loan defaults with this model, then the description that users put into the application to apply for a loan, the description is super critical. And for example, if I click on Insights, we provide the user also with these typical, you know them, these typical word clouds. And it's not just that we highlight the number of appearances for these words or phrases. So how often a word or a phrase shows up in the description. We also highlight if it is highly correlated to a loan that defaults, then it would be red, or a loan that would not default, which is then the color blue. Yeah. So we can use these visualizations to help understanding what the model is all about. Yeah. So you see the feature impacts. You see also feature effects. So in this case, you see on the y-axis, you see the probability that a loan defaults, and you see that it significantly drops with an annual income of 50K or plus, and then again drops at around about 65K. So if someone has an annual income of, let's say, 60 or 80K, we already know that the probability that the loan defaults is significantly lower. Yeah. So this is also something that you can use to have a very good discussion with the business with. And last but not least, you can even ask DataRobot why does DataRobot comes up with certain predictions. And in this case, DataRobot gives you 4 high risk loans and 3 low risk loans. So for example, the first one, probability that it defaults is 83%. And now DataRobot also provides some dates that show you why DataRobot is coming up with this high prediction. Yeah, because the title is small business loan. The annual income is only 50K. The term is 60 months. Yeah, versus a loan with a low risk to default. For example, the last one here, you see that the interest rate is relatively low. That's a good signal. The annual income is relatively high with 120K. So again, something that you can use to really have a very fact-based discussion with the business to decide, okay, is it a good model that we want to bring in production or not? And if it is the case, that's the second step of the 2-step approach, and the last step in this demo, that you can directly go to predict here in the blueprint, and you could pick any blueprint out of this leaderboard. But if we would pick the blueprint recommended for deployment, we could directly deploy this model and use it for future data. So we could do a batch upload and just upload the next 10,000 loans, for example. You could even download the scoring code, so you could run the model without DataRobot. And it's important to know that we allow this because we don't want that you use it without DataRobot, but we are convinced that partners and customers, they should own their AI IP. That's super important, and that differentiates us from from our competitors. So it's your IP, so you always have the chance to download the scoring code, or, and that's the most important, most often used deployment option, is you can directly deploy this model. Let me click on deploy model. Let me give this a name. Let's call it PUE session. Change this, and I create deployment, and you recognize within 2 seconds this model is deployed. It is now deployed on a separate dedicated prediction server, and it serves like a REST API endpoint. So if I would give you the respective API token now, you would be able to directly connect to this model from an external application like a BI application, an RPA application, or a custom application. And we also support applications within DataRobot. So what I can do, you recognize this applications button here. What I can do, I already created a short application. It only takes one minute or so to create them. I created this application for this model. I open it, and I can directly use the model that we just created. So I click create a record. I give it a name. I do not make a description here. I use the average values, and now I click get prediction. And as soon as I click get prediction, DataRobot sends the application sends the main data to the DataRobot platform, to the model. The DataRobot calculates the probability that a loan defaults based on these parameters, and bounces back the prediction. And you see not only the prediction, it's pretty low, so that would be a loan that we would default, that we would invest in. But you recognize the prediction explanations. So we do not only provide them for the historical data, but also for future data. So if someone would ask okay, why, perhaps in another case, why will you not give me the money? Then I could say, okay, these are the reasons why I would not trust this investment, and I would not invest in this loan. So relatively easy to build these predictions or to connect from other applications. And that was basically the real world scenario I wanted to walk you through. We can go back to the first tab. You see DataRobot is still working, but we're already at 64%, and I bet until 12 o'clock we will have all models trained. And for example, if I look to the leaderboard that we just picked the blueprints from, you recognize at the end we will have 89 models, 89 different algorithms, 89 different blueprints that we trained during this PUE session. And we also deployed one of the models. We validated it, and we deployed one model and brought it into production within 30 minutes, 45 minutes. I think this is a good example of how fast you can come up with new AI models. Not for all use cases, I'm well aware of it. And of course, it is a test data set, and you have to work on the data and do data preparation and all these things. But it is a lot faster than let's say the traditional way. So let me wrap up. You have seen different kinds of data that we used for the prediction. As said, DataRobot is also able to use images. Yeah. So if you have a use case where you want to analyze images, you can, the same way you can just drag and drop these images into the DataRobot platform. You can combine text, images, and numbers, for example. Also geospatial data if you have them. you see within the, I don't know if you can see it, there are some parts of these images highlighted. So DataRobot even shows you where DataRobot looks within the picture to do some predictions. And last but not least, you would also not have to use any special hardware, so no graphical, no GPUs are needed. So with classic traditional hardware, you can even build models with the use of visual AI. I mentioned the skills that are required to execute AI projects. You definitely have to have the domain expertise. You have to understand the business problem and the data. Normally, you would have to have the skills to write code, build models, implement models, manipulate data, and you have to have math and stats expertise. And for most of the use cases, for a high number of use cases, high percentage of use cases, we are able to automate a high degree of the entire development life cycle by using a platform like DataRobot. And I hope it became obvious in this session. If you're interested, please let us know, let PUE know. There are a couple of interesting sources of information, our homepage, our community, the Pathfinder, where you find more than 100 different kinds of use cases for different industries that you can have a look at, or even our DataRobot University, if you are interested in some first trainings and certifications. There are even classes for free, so feel free to use them. And with this, I thank you for your participation in this session. I hope it was interesting for you, and I'm looking forward to hearing from you. And thanks again to the entire PUE team for having DataRobot and having me in this session. Back to you, Adrian.
Yes, thank you very much, Mr. Boyce. It was not only an interesting but also a practical session. Don't leave the session yet, because we will back with you in a few seconds to solve some questions from our audience.